Okay, I will quickly go through the 8-puzzle problem here, first by running the code, giving the user option of the starting states. Start with breadth first search, get this output, we can run it again, do medium, do an A star, and use the Manhattan distance, and get this output. Initially we set the initial states for easy, medium, and hard. We set the goal state, ask the user for search strategies, breadth first, depth first, uniform cost, best first, and A star. Each of these have a heuristic, but for the first three, that is just a placeholder. And for best first, we're given that misplaced tiles is the heuristic. And for A star, you're given the option between the misplaced tiles and the Manhattan distances. If the user does not input correctly, it sends an error message and exits the system. First, we initialize with the constructor function. Then we define the heuristic costs. With no heuristic, that default again was 0. For the misplaced tiles, we take the tuple of the initial and the goal state. If they don't match, we add 1 and find how many there are misplaced. Then to find the Manhattan distances, we iterate through the goal state and add to the cost the absolute value between where the tile is, or where the tile should be minus where the tile is. Then we define all of the sets of moves, and then we define how to move a tile between left, right, up, or down. And the cost of each move is the value of the tile itself. So the move tile cost is where it is at the state. Then we initialize the queue, and pulling from the queue depends on the search strategy, either from the beginning for breadth first, from the end for depth first. Sorting from the beginning on G of n for uniform cost, and best first on H of n, and for A star we sort and pull from the beginning of H of n plus G of n. And we initialize our solver class, and we start our stopwatch during the solving process. We build out the max length of the queue. We determine if the goal was reached. We make sure that the states aren't repeated as we go through. If it's not a repeat state, we add a move. We iterate through each of the nodes, and we return the modified state and the relative cost. We make a new node, then add to the tree. For any search strategies that involve the cost, we base that on either the G of n for uniform search, H of n for best first, and the adding those together for A star. Then we check in the queue if the state was there. If it is, then we make sure that it was the existing was more than the new, and if it is, then we remove that from the queue. Otherwise, we're in depth first and we start at the back. Else we're in breadth first and we start at the beginning. Again, based on search algorithm, we end the main loop and the stopwatch. We iterate through the tree, find the goal state, get the end node, and then use that to find the path back to the root. And then we print out all of the results.